So today we will be talking about differential equations. So generally, what is meant by a differential equation? When we talk about differential, we mean differentiation. So dy by dx. All right. So this is a differentiation of dy by dx. When we talk about a differential equation, we mean dy by dx, for example, plus y plus x equal 5 or something like that. So we basically have an equation where we have a differential in it. This is what is known as a differential equation. I'm pretty sure you guys have seen linear differential equations back in Math 1. Linear meaning that the power is only 1. This is just the first differentiation. So this is a first order differential equation. Why is it first order? Because it's only the first differentiation. There isn't a power of 2 or anything like that. It is only dy by dx. All right. Another form or another way of writing this is instead of dy by dx, we usually write y prime plus y plus x equal 5. Okay. This is known as a differential equation as well. This is just a different form of writing the differentiation of y by x. This is known as a non-homogeneous equation. Why is it non-homogeneous? Because here we have a value. This will make it non-homogeneous. Non-homogeneous basically means that your differential equation is equal to a value, all right? No matter what the value, there is a value in here. If we had a y prime is equal to, or plus y, the same equation, plus x equals 0, this is known as a homogeneous equation. Homogeneous meaning that it is equal to 0. There's no other function. There's no other constant here. And then this is known, this is a homogeneous equation. And in our case, we are always going to be dealing with homogeneous equations. Okay. To begin, okay, first, let us look at what a second order. So this was a first order differential equation. You've seen this already before. You usually do it using separation of variables and all of that. Okay. But what is a second order differential equation? An example of a second order differential equation will be something as simple as having, for example, زين من التشيز قاعد اطلع هذا, it's 4dy by dx, d squared, I should say, of y by dx squared plus 5dy by dx plus, for example, 3y is equal to 0. All right. Again, all the equations that we are going to be dealing with are going to be homogeneous, meaning they're going to be equal to 0. All right, in our case. So this is what a second order differential equation is. So in other words, if we want to rewrite this, this is 4y prime or double prime plus 5y prime plus 3y equal to 0. All right. This is usually how the form of a second order differential equation will come. So basically you have the second derivative, the first derivative, and just the y function itself. And the idea here is you want to find a solution for y. Okay, you want to find y is equal to something, something, something. All right, this is how you solve a differential equation. Basically, you're going to get it in the way where you have y is equal to some specific value. Okay, so if we look at this from a theoretical point of view, all right, so our standard equation is in the form of a y double prime plus b, a constant b, times y prime plus c times y is equal to 0. All right, this is also known as the characteristic equation. All right, this is just another naming. So the idea, like I said earlier, is we are trying to find something called a general solution, which is our y. All right, it's known as our general solution. What is done, or how the theoretical way of how to solve it is, y is assumed to be e to the power. This is just an assumption, all right? Assumption is y is equal to, just 1 second. So y is equal to e to the power of rx, okay? This is what is usually done. This is just an assumption. So when we know that the value for y here is equal to e to the power of x, we are making that as an assumption. Y prime will be re to the power of rx, all right? You don't need to memorize any of this. This is just the theory. If you differentiate y in terms of x, remember, you're just going to take the r outside and multiply. And the second differentiation is going to be r squared e to the power of r x. Okay? So this is just based on the assumption. We're just assuming a random value for y. All right, and the value is in the term of exponential, and you will see why now. So if we substitute this now back into our equation here, we are gonna get a. So this is y double prime, which is this value over here, r squared e to the power of rx. So we're gonna be getting r squared e to the power of rx. Okay, I'm not gonna put brackets, I'm just gonna put it directly, plus b times y prime. Y prime is the value that we have found here, plus b times y prime, which is r e r x, plus c times y, which is our original assumption over here. This y is basically this value over here for y, which is e to the power of rx. And this is equal to 0. Okay? Now, what can we do here? We can take e to the power of rx as a common between all of them, and it is available in all of them. So if we take e to the power of rx as common, all right, we're going to be left with, for the first one, ar squared plus br plus c, and this is all equal to 0. All I did was take e to the power of rx common. And now if we divide both sides by e to the power of rx, we can cancel it out directly because 0 over anything is just 0. So, and here we will be able to cancel these two out. So we are left with this characteristic equation, ar squared plus br plus c is equal to 0. Okay? And now you can solve this as a general quadratic equation. This is the whole idea. So obviously this works only for a homogeneous equation, all right? And we are only going to be dealing with a homogeneous, meaning it's equal to 0. And we have a general way of solving this equation now, okay? So how would we solve this equation? Using mode 5.3, using factorization, using whatever method you like, whatever method you prefer. But we are going to have 3 different cases or 3 different answers and values, which we will be looking at right now. So first case is, let us say we are having, let's give numbers for a, b, and c, all right? So let's say we have this equation, r squared, or actually, let me write it in differential equation form. So let's write it in this form, and then we can plug it in to this form. So for the first case, let's say we have dy by dx squared minus 5, all right, times dy by dx plus 6y is equal to 0. So in this case, our value for a is 1. Our value for b is 5. So this is our a value, which is 1, which is not mentioned. Our b value is 5. And our c value is 6. If we transform this into our characteristic equation, this is going to be 1 times r squared plus b times, which is in this case 5, r plus c times, which is in this case 6, equal to 0. And now you can very easily solve this using either mode 5.3, using a quadratic equation, using factorization. Me, I personally prefer using quadratic, and I'm going to use it for the first few cases just to explain the concept of the cases that you might have. So this is for case 1. Okay? Case 1 is when we find our b squared, if you remember the quadratic equation, so r1, 2 is going to be equal to minus b plus or minus the square root of b squared minus 4ac over 2a. All right? If you remember this equation. All right? I know you guys usually use mode 5.3, but for now, let's just use this one. So this is going to be equal to minus b, which is negative 5, plus or minus the square root of b squared minus 4ac, which is 5 squared, which is 25, minus 4 times a, which is 1, times c, which is 6, divided by 2 times a, which is 1 in this case. Okay? If we simplify this, this is minus 5 plus or minus 25 minus 4 times 1 times 6. This is the square root of 25 minus 24. And if you notice here, this is the important part. Our b squared minus 4ac is a positive number. All right? This is for case number 1. This is what is meant by the first case. So our b squared minus 4ac is going to be a positive number, which is just going to be 1 in this case. What does this mean? This means that when we solve this now, this is going to be divided by 2, which is equal to minus 5 plus or minus square root 1 over 2, which is equal to minus 5 plus or minus 1 over 2. All right, this is for R1 and 2. This means that R1 is going to be minus 5 plus 1 over 2, and R2 is equal to minus 5 minus 1 over 2. In other words, if we simplify, R1 is minus 5 plus 1 is negative 4 divided by 2 is minus 2, and R2 is negative 5 minus 1 divided by 2, that's minus 6 over 2, which is minus 3. When we have this case 1, which is b squared minus 4ac is greater than 0, in other words, this means that we have two real distinct roots. شو معناته؟ معناته they are real values, not complex. You don't have I or J. And they are distinct, meaning they're not equal to each other. All right? So why are we finding these roots to begin with? What's the whole point of finding these roots? We are trying to find our solution. Remember, our solution is simply y. Y, which is equal to, in this case, in our assumption, e to the power of rx. So now we can say that y is equal to e to the power of rx, all right, r1x, plus e to the power of r2x. And there is going to be a constant that is multiplied with this as well. So c1 e to the power of rx plus c2 e to the power of rx. This is a constant that is multiplied because we made this based on an assumption. We don't know what the constants are, and these constants depend on something called the initial values or the boundary conditions, which we will be looking at later on. But for now, what you need to know is that this is our general solution for case 1. All right, so this is our general solution. General solution. Okay. In our case here, we already have found our values for R1 and R2. So we just have to plug them in to R1 and R2 over here. So this is going to be Y is equal to C1E. R1 is negative 2x plus C2E. R2 is negative 3x. And this is your final general solution for this case 1. Okay? Is it clear so far? How is it plus 5? Isn't it minus 5? Oops, I put the wrong value. Yeah, it's supposed to be minus 5. Let's just, for the sake of... there you go. All right. I was supposed to put minus 5, but I was just solving very quickly. I did not notice that. Okay. So, minus 5. All right. Minus 5 plus 1. Yeah, okay. Everything else is clear. All right. So the idea here is obviously don't make mathematical mistakes in copying like I did. ولكن the idea here is when you have the root or under the square root, when you have two distinct real roots, يعني الأجوبة اللي تحصلونها from the quadratic is minus 3 and minus 2 or 10 and 5 or 6 and 7. These are known as two real distinct roots. معناتها you will be applying this general solution. Okay, which is C1E R1x plus C2E R2x for a second order differential equation. All right. Now, this was our first case. Let's look at our second case. Our second case is, let's call this case 2. If they are -2 and +2, they are not multiples. They are considered distinct. They are the same exact. The question he was asking is, what if I got -2 and +2? These are considered distinct. They are not the same value. They're not equal to each other. All right. I usually call them C1 and C2. You can call them A and B. That's up to you. It is just a constant. You can find them in any way you want. And I have learned it in this way. That's why I am teaching it in this way. All right. They're exactly the same thing. Okay. So let's go on to case number 2. Again, the same exact idea. We were going to be given a differential equation. Let us say we have y double prime minus 6y prime plus 9 is equal to 0. Okay? Again, we are going to put this into our general form, which is going to be r squared minus 6r plus 9 equal 0. This is 9y. All right? So now we can solve this again using a quadratic equation that we have applied early on here. I'm just going to keep copy pasting this. So we're going to be solving using a quadratic equation. All right. معناته this is equal to minus b, which is 6, plus or minus the square root of b squared, which is minus 6 squared, which is 36, minus 4 times 1 times 9, divided by 2 or times 1. Simplifying this will give us 36 minus 4 times 9 is 36. Yes, it is -6, but the equation is minus b. So you'll be doing minus 6. All right. So 36 minus 36. Again, you guys just use mod 5.3. I'm just doing this for explanation purpose. All right. Divided by 2 over 1. If you notice now, in this case, our b squared minus 4ac is going to be equal to 0. So this is our second case where b squared minus 4ac is equal to 0. This is case 2. Okay? What does this mean? Let us see what that means. Now, if we find or solve for R1, 2, this is equal to 6. This is going to be 0. So 6 over 2, which is equal to 3. Meaning that R1 is equal to 3 and R2 is equal to 3. This is what is meant by having two multiple roots. Or not even two multiple roots, just saying multiple roots. Or in the case of quadratic, it is one root. All right? Multiple roots is for when you have higher order differential equation, but here we have one root. In other words, معناته repeated root. Okay? So we have a repeated root, and R1 and R2 are equal both to 3. Okay, yeah, I'm not sure if they want steps or not. If you want steps, you can do this, and it will be very easy for you guys. All right? So one root, meaning that we have R1 equal to 3 and R2 is equal to 3. Remember that our y, the assumption that we made at the very beginning is e to the power of x, to the power of rx. All right? This was the assumption we made at the very beginning. But because we have two r's, it's going to be r1x plus e to the power of r2x. And we are going to have a constant 1 here and a second constant here. But if you notice, r1 and r2 are equal in this case, meaning that these two values, these two are the exact same solution. And that is not possible there's no point in finding a solution like that, because in the repeated root, we will have to add an extra x here for each repeated root. All right. This is the general solution for case 2. General solution for case 2. Okay? This is how you will have it. You cannot have the same r multiplied. يعني حين, for our example, y is going to be equal to c1 e to the power of r1, which is 3x, plus c2 e to the power of 3x. It is the exact same solution, which makes no sense. Therefore, there has to be an x multiplier here. You don't need to know why there is an x multiplier here. You just need to know that that it exists. That's all. All right. So for a repeated root, you have to add the extra x over here. Okay. Now, this was our second case. So we have already found our general solution. C1 and C2, you can find them, like I said earlier, if you have your particular, if you have your boundary problems, which we're going to look at, if you have your boundary conditions. But in this case, we do not, so we keep it as it is. To find the general solution, it depends on the question. Let's move on to the last case, which is case 3. نستخدم شو أي لون أول أزرق. يلا خلها أخضر عيل. All right, so case 3. What is case 3? Let's take an example. So we have y double prime plus 8 y prime plus, let's make a large number here, خلينا نحط 25 equal 0. All right. So y prime plus 8 y prime plus 25 equals 0. Before I move on, someone actually mentioned a good point. Yes, you can do that. You can say that this is y equal to e to the power of 3x will be common factor. So it's going to be c1 plus c2x times e to the power of 3x. You can have this as your general solution as well. There is nothing wrong with it, but it's good to understand where it is coming from. All right. But this is also an acceptable answer. Now, back to this problem, case 3. Y. There's a y here. All right. Again, we're going to apply our, and we're going to find our characteristic equation, اللي هو r squared plus 8r plus 25, which is equal to 0. All right. Simple. We apply our quadratic formula, which is this formula over here. We're going to be applying the quadratic formula. All right. So now we have minus b, which is in this case positive 8 is b. So minus b will become negative 8 plus or minus square root of b squared minus 4ac. Move this a bit to the left. B squared minus 4ac. So it's 8 squared, which is 64, minus 4 times 1 times 25. All over 2 times 1, 2 times a. All right. You can have an actual value for a other than 1, but I'm using 1 for simplicity only. All right. So if we simplify this, it's minus 8 plus or minus the square root of 64. 4 times 25 is 100. So this will become 64 minus 100 over 2. What do we notice here? We notice that our b squared minus 4ac now is negative. We're going to get a negative value. يعني our third case is when b squared minus 4ac is less than 0. This is case 3. All right. So for this case, if we simplify this now, you're going to see that our roots r1 and 2 are going to be equal to minus 8 plus or minus the square root of 64 minus 100. That's negative 36 over 21. If you guys do not know, the square root of negative 36 is going to be equal to, so minus 8 plus or minus, it's going to be 6 times I. When you have a negative value, that is basically an I when you have the square root of minus 1, because I is equal to the square root of minus 1. All right. So it is a complex number. This is what is known as a complex number. All right, this is 2, not 21, my bad. Okay, divided by 2. So what I did here, when you do the square root of minus 36, that's the same as saying the square root of 36 times the square root of minus 1, all right, which is just I. Okay, simplifying this, we're going to get R1 is equal to minus 8 plus 6. Actually, let's keep it as R12 plus or minus 6. We can simplify this more by dividing the upper part by 2. We are going to have minus 4 plus or minus 3i. All right, 8 divided by 2 or negative 8 divided by 2 is negative 4. And then 6 divided by 2 is 3. Okay, R1 now is equal to minus 4 plus 3i. And R2 is equal to minus 4 minus 3i. This is known as our third case, which is you have complex roots. Complex meaning they have I in them. They have a complex number, a complex part of it. All right. So I'm pretty sure all of you know what complex roots are. Most of you have already done computing. You've seen it a lot there as well. So what will be the solution in this case? So first things first, let's have a general form of this. So R1 is equal to alpha plus beta or plus or minus beta I. All right, so R1, 2. So let's say the real part is alpha. So this is the real part. And this is the complex part. All right, just to have a general form when we have a complex part. The answer of the square root, before I move on, again, I will repeat this just one more time. You will do the square root of 36. If you have a negative number, you're just going to multiply I with whatever the square root of the positive number is. يعني بتساوون square root 36, which is 6. And then you're going to multiply it by I because it is negative. Okay? So again, we are just having a general form for R12, where this is our real part and this is our complex part. So if we want to find our general solution, y is equal to, remember, y is equal to e to the power of rx based on our assumption. In this case, our r is equal to alpha. It is equal to alpha plus or minus beta I times x. Okay? Don't get too confused by this. You're going to see this, especially electrical students. You're going to see in the future how this becomes e to the power of alpha times the complex parts turn into cosine of beta x plus sine of beta x. All right. And of course, we're going to have our constant C1 and C2 for each of these terms. All right. And there's going to be an x here. This is alpha x. Okay. So this is going to be your general form. Again, let's تعورون راسكم on how this transforms into this. There is a mathematical proof for it, but this is why you see this. So the idea is you are still plugging it back into e to the power of rx, but when you actually look at the general form, so I'm just going to keep this here small just as a note. But your general form, as you've seen it a lot in your studies, it is going to be in C1 cosine beta x, C2 sine beta x, and outside is e to the power of alpha x, where alpha is our real part and beta is our complex part. And this is our third and last case for a second order differential equation, where we have complex roots. So this is for case 3, general solution. Okay? Meaning, we saw 3 examples for 3 different cases. Now we can solve for any different case. So how are we going to plug this into our general equation for the example we solved? It's going to be e to the power of alpha. E to the power of alpha. What is our alpha value? Our alpha value is negative 4. All right? So it's going to be minus 4x into C1 cosine beta, which is our imaginary part in this case. The first one Again, this is just beta, the absolute value, like it's plus or minus. So this is just the actual beta value. Without the minus, without the plus, it's just plus for both, all right? So cosine 3x plus C2 sine 3x, okay? The reason why it's the plus part is because the negative one turns into cosine and the positive one turns into sine. So they're both just and just that. And this is your final solution, or your general solution, I should say, for the third case. There is no fourth case because we are talking about second order. In higher order, we're going to have that fourth case or a possibility of that fourth case. But I need you guys to make sure you understand what I have done here. All right. Again, I will repeat how I plugged these values in. So our real is -4. All right. Our real is -4. This is our real value. So our real value is going to go for alpha. Okay, this is our real value. We have plugged it in for alpha. This is the real value. The complex value is 3. All right, ignore the sign because you have plus and minus. All right, so the real or the complex part is the 3. The 3 is going to be plugged in for beta. All right, this is our complex part. So the complex part is going to be here as 3 and 3. I believe you will be receiving the equation for the test, but you will not be told what solution this is for. Yani you will not know which case this solution is for. You're just going to have it. I think so. I'm not sure. Someone can correct me if I am wrong, but I believe you will be given these equations, but it will not mention for which case. Yani you will only be given this equation. والباقي عليك. إنزين؟ Let's look at some actual examples now. All right. And I'm not going to look at the easy examples that are just there. I'm going to look at the ones that somewhat look hard. They're not actually hard, but they just look hard because they look scary. And for example, this one. And then I'm talking about second order equations now. Let us look at this question. All right. And I will also explain the point of a particular solution that I still did not go over. So again, so far what we have done is just the general solution. The general solution meaning the general meaning we still have constants in our equation. Yani we cannot determine the constants. All right. In this question, we will be determining the constants and you will see how. But first, let us solve for the particular solution or for the general solution. This will always be your first step, even if you have your boundary values and all of that. You will always be solving. Sorry, you will always be solving your general solution first. وبعدين you're going to be applying. So let's look at this question. The motion of the pointer of a galvanometer about this position of equilibrium, blah, blah, blah. مو مهم. الإكويشن مالكم is I theta double prime plus K theta prime plus F theta equal 0. And then this is the form of your equation. They tell you that I is this, which is 5 times 10 minus 3. That's all you care about. So your I is 5 times 10 to the minus 3. Theta double prime. Plus K, the resistance due to blah, 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 is 2 times 10 to the minus 2. All right? يعني لا يخربطكم الكلام. Okay? Plus F. So this was our K. F is the force on مدري منو عند مدري شنو ومدري شنو is 0.20. All right? So all you care about is the actual value times theta equal 0. All right? Now solve the equation for theta in terms of t, given that, and we will look at this about this in a bit, given that when t equals 0, theta equals 0.2 and d theta blah 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 blah. بنشوفها هذا in a bit. This is for solving for the particular solution, which I will talk about in a bit. All right. But first, let us solve and get the general solution of this. First step is get it into your standard characteristic equation, which is known as the auxiliary equation as well. Yani 5 times 10 to the minus 3 theta double prime turns into r squared, or I believe you guys are using m squared as well. I'm going to use m squared here just so you guys, so it fits as well what you guys are used to doing. Plus 2 times 10 minus 2. Theta 1 is going to become m, or theta prime, plus 0.20 equal 0. Again, we are going to be applying our quadratic equation. So m12 is equal to minus b, which is 2 times 10 to the power of minus 2, plus or minus the square root of b squared, which is 2 times 10 to the power of minus 2 squared, minus 4a, which is 5 times 10 to the minus 3, times c, which is 0.20. Okay, let me move this a bit to the left. All right, so this is your quadratic equation, of course, divided by 2a, which is 2 times 5 times 10 to the minus 3. Okay, again, reminder, this is your a, this is your b, and this is your c. Okay, solving this, let me just grab my calculator. The first thing you're going to check for is this part. If it's positive, if it's 0, if it's negative, so you can instantly know what type of solution you are going to be looking forward to. طبعا, from the final solution, you will know directly what it will be, but this will also help you detect what the actual thing will be. So minus 4 times 5 times 10 to the power minus 3 times 0.20 is equal to, the fact this gave me math error معناته it's a negative number. Just 1 second, let me get my other calculator. And then, so again, 2 times 10 to the power of minus 2 squared minus 4 times 5 times 10 to the power minus 3 times 0.2. And then this gives me a negative value under the square root. So m12 is equal to minus 2 times 10 to the power minus 2 plus or minus square root of minus 3.6 times 10 to the minus 3. Since we got a negative value inside here, we know that this is going to be a complex number. We know that we're going to have a complex solution. So 5 times 10 to the minus 3. Actually, let me simplify this as well. This is just 10 times 10 to the minus 3. So it is 0.01. All right. Okay. So if I square root this in complex mode, you are going to get, or if you want, you can do the positive part in your calculator and then just put I to the minus. And you're going to square root it, and then you're just going to put I outside because you already know it is multiplied by I. Meaning, you can do this 2 times 10 to the power minus 2 plus or minus I times the square root of positive 3.6 times 10 to the minus 3. Then you know you have a square root minus 1 inside. You can just take this outside if you don't want to do it through the calculator, over 0.01. So m12 is equal to minus 2 times 10 to the negative 2, which is just minus 0.02, plus or minus the square root of this is going to be 0.06 I. All right. If we divide all of this now by 0.01, m12 is going to be equal to, so negative 0.02 divided by 0.01 is simply just minus 2, and 0.06 divided by 0.01 is just 6i. Okay. If you want to use complex in the calculator, if you have the same calculator I have, you're going to hit mode. I'm going to put this as a note here. You're going to do mode 2. Okay. And then you will notice at the top of your calculator, it's going to say CMPLX. And then you can put this value directly, the square root of minus 3 0.6 times 10 to the power minus 3, and it will give you the value as 3 over 50 I. Okay? If you want to use complex in your calculator, you can. Nothing wrong with that. And it doesn't change anything else. And you can do normal calculations as well with it. Okay? So mode 2 in your calculator will turn it into the complex mode. And you can do complex number, basically algebra. Complex algebra. All right? المهم, so we got this for our M1 and 2. So this is our alpha. What color did I use for alpha? I think purple. This is alpha. And this is our beta value. Our general solution is y is equal to e to the power of alpha x c1 cosine alpha beta x plus c2 sine beta x. All right. So we're just going to plug in our values now. So E alpha is negative 2x C1 cosine beta. Oh, all right. I made a mistake here. I wrote y and x, but our function is in theta and in time. So if you notice here, we have theta and we have t. So basically, we are going to replace our y is going to be theta, and our x is going to be the letter t. Okay, so the general solution is going to be the same, but what I'm going to be doing is I'm going to be writing theta here, and I'm going to be writing t over here instead of x. Okay, so C1 cosine beta, which is 6 times t plus C2 sine 6t. All right, and this is our general solution. Before I move on to particular, is this clear? Anyone has any questions? Then I don't want to move on from this step. And if you understand what I've done here, you're going to be able to solve for any type, even in higher order. إذا عندكم أسئلة, please ask right now about this. Did you use mode complex? I did not. I did the actual mathematical calculation with steps. All right. Like I said, when we are dealing with complex, you are going to take just the value of 6 because you have a positive and a negative 6. Technically, the negative part is the cosine and the positive part is the sine, technically. Okay? عشان شي, we are just going to use the value 6 in the case of complex. تمام? We are not going to look at minus or plus. We're just going to take the value as it is, a positive value, and plug it into our beta. You can use the complex mode here. Yes, you can use complex and then you can do mode 5.3 and you can find it out. Of course, best apparently in the exam they're going to check for steps. I am solving with complete steps with almost zero calculator usage عشان تشوفون how I am doing it without a calculator. All right. انزين نشوف. Will this equation come in the formula sheet? Based on what I know, it should be coming. Just this equation. Just this by itself. What I know, this equation is going to be coming. Tomorrow I will confirm for you guys. Best, what I believe is they're going to be giving you all the equations, but you guys have to understand what the equations mean. And maybe instead of C1, they're using A and B here or whatever. يعني you just have to understand how the equation is. في ساين إذا حطيت الرقم صالب ما يفرق صح؟ قصدك في الكوساين مو في الساين، بس صح كلامك. في الكوساين إذا حطيت السالب ما يفرق. بس I don't want to confuse people right now. Just keep it as a positive value right now. مو في الساين في الكوساين. Why did you put t instead of x? Perfect. So here in the question, we are given d theta by dt. So in the question, we are given as d theta by dt, not dy by dx. So I replaced the y with theta and I replaced the x with t. That's the reason why. Then the السؤال is in theta and in t. For case 1 and case 2 also, yes. For case 1 and 2 also, yes. شلون تستخدمها في الحاسبة؟ مثل ما قلت, you're just going to do mode 2 complex, and then you're just going to be plugging in just this part. The plus or minus, you're not going to be able to solve on the calculator because you're going to have two parts of this equation. So maybe there is a way, but what you're going to do is just you're going to plug this in, or you can just use mode 5.3. يعني another way is using mode 5.3 while in complex. يعني أول شيء سووا mode 2 عشان الكالكوليتر يتحول complex. At the top of the calculator you see complex. بعدين you're going to do mode 5.3 and it will find out the solution. It will give you -2 plus 6i and then -2 minus 6i. x1 or x2 يعني. All right? So now we have we haven't finished the question. We have only done the general solution. All right? So this is just the general solution. But the question gave us boundary conditions or initial value problem. This is what they usually call it. عطانا given that when t equals 0, theta is equal to 0.3. Let me write that down from now. So when t is equal to 0, theta is equal to 0.3. And another condition they gave us is and d theta by dt is equal to 0. So معناته when t is 0, theta is equal to 0.3 and d theta by dt is equal to 0. So our second condition is when t is equal to 0, d theta by dt, or you can say theta prime, is equal to 0. All right? This is our boundary conditions. These are known as either our initial values or our boundary conditions. All right? مسمى بس. Usually you guys know them as initial values. When you are given initial values in any question, that means you need to solve for the particular solution. Right? When you are given this, معناته you need to solve for your particular solution. How do you solve for a particular solution? Using the general solution that we have generated. How do we do that? Simple. Very simple. So now you're going to put this down here. All right? You are going to find the differentiation of theta. So you're going to find theta prime, which is equal to. How do you do theta prime here? يلا منو اللي بيخبرني? I want to see how good or bad you guys are at your differentiation. How can you find your theta prime here? يلا عاد مو لهالدرجة. So you're doing d theta by dt. How would you do it? Exactly. We're going to be using product rule. All right. So if you want to, if I'm going to, for only one time, I will go through the full steps of product rule. If you guys want to remember product rule, you're going to look at my previous videos. We're going to call this U, and we're going to call everything here in this bracket as V. And then, so to find theta prime, we need to do U times V prime plus V times U prime. Okay, basic differentiation. So before we do that, we need to find our U prime and our V prime. So what is our U prime? U is E minus 2t. شنو differentiation ماله? It's going to become minus 2 e to the power minus 2t. I am not going to explain why this is the differentiation. You guys should know that very well by now. And V prime is going to be C1 is a constant. It stays the same, but we have a 6 inside. So it's going to become 6 times C1. It's cosine, so it becomes negative sine of 6t. Plus C2 is a constant, so it stays the same. 6 times C2, so it's 6C2 cosine 6t. All right. Again, the differentiation here is very simple. You're just multiplying, you remember chain rule, 6 times outside. C1 is just like a number. It's a 5, 10, 20. It's just a constant. ما يتأثر. It stays the same way. Cosine becomes minus sine, and sine becomes cosine. Minus 6, again, the minus 6 here is because cosine of anything, the differentiation of it is minus sine. But we have to multiply the whole thing by minus. Okay? So cosine becomes minus sine. That is why we put a minus 6 here. Okay? So now we can find our theta prime is equal to u times v prime, which is u e to the power minus 2t, times v prime. So this is our u. V prime is all of this. مالي خلق أرد أكتبه, so I'm just going to copy paste it here. Okay. Plus V, which is all of this. Again, too lazy to write it all down, so I'm just going to copy paste it here and make it smaller. Times, let me move this to the left, times U prime. What is U prime? Minus 2 E T over here. Okay. My recommendation, do not simplify anything yet. All right. I will show you why in a bit. Okay. Keep it the same way it is. Why are we finding this prime? It didn't copy the minus. Thank you. So it's minus 6 here. Thank you. So why are we finding U prime or theta prime? لأن الboundary conditions we have it for one value, but we have two constants we need. Two unknowns means we need two equations. The first equation is the theta that we have, the original equation. The second equation is our d theta by dt, which is our theta prime equation, because we have the conditions for that. So now let's apply the first one, which is t0. When t is 0, theta is equal to 0.3, which is our original equation, this equation right here. All right? Okay, so what does this mean? This means that theta, we're going to remove it, it's going to be 0.3. So this theta is 0.3, and t equals 0. We are going to replace all the t's here with 0. So this is 0, this is 0, and this is 0. Okay? E to the power of 0 is what? E to the power, anything to the power of 0 is what? So we have 0.3 is equal to, anything to the power of 0 is just 1. All right? C1 is our constant times cosine of 0 is 1. 6 times 0 is 0. Cosine of 0 is 1. Plus C2 times sine of 0 is 0. So here directly we can find that C1 value. So 0.3 is equal to C1. 1 times C1 times 1 is just C1. So now we have found our first value. C1 is equal to 0.3 using the first equation. Now, C2 is not 0. Sine of 0 is 0. All right? So sine 0 is equal to 0. C2 times 0 is equal to 0. All right? Sine of 0 is equal to 0. عوضوا حطوا في الكالكوليتر. لا تعورون راسكم. عوضوا حطوا sign of 0 in the calculator. See what you get. You get 0. خلاص. You multiply this by 0. Any number times 0 is just 0. It's just simple substitution. So here for the first case is for our theta. Our second boundary condition or initial value is for theta prime. So this is for our second case. And we already have the equation of over here. So I'm just going to copy paste this down here. And again, ليش قلت لكم لا تعورون راسكم بس عوضوا. So we know that theta prime is 0. All right? Theta prime is 0. And t is also equal to 0. So we're just going to replace all our t values with 0. So this is 0. Here as well, we're going to be removing t. We're going to be removing t, and we're going to be putting 0 and 0. And then we're removing t here. We're removing t here. We're going to be putting 0 and 0. And we're going to be removing t at the very end. And we're also going to be putting 0. Okay, and now step by step. So we have 0 is equal to e to the power of 0 is 1. Minus 6 C1 sine of 0. So we have sine of 0 here. معناته this is 0. Just a reminder, this is equal to 0. Sine of 0 is basically 0. So this whole part becomes 0. Plus cosine of 0 is 1. Remember, cosine of 0 is not 0. Cosine of 0 is 1. So it's going to be 6 times 1. Okay? Oops. So this is for our first part. Plus, second part, we are looking at this now. Cosine of 0. What is the cosine of 0? It is 1. Plus, or actually it's not 1, it is C1. I'm sorry, I forgot about my C1 and C2 values. So here we have 6 C2 times 1. And here we have C1 times 1. All right? I forgot about my C2 and C1 values. C2 sine of 0 is just 0, so this becomes all 0. And this just becomes 1. E to the power of 0 is just 1. Sorry, it becomes minus 2. لأن عندنا الماينس 2 outside times 1. Okay? لأن عندنا هنا minus 2 times e to the power of 0, which is 1. All right. Let's simplify now and solve. We have already found the value for C1 earlier, which is 0.3. فنقدر نعوض حتى حق C1 value هني as 0.3. All right? This is just the C1 value. So 0 is equal to, let's make this a bit cleaner. So this is 6C2 plus 0.3 times minus 2. Okay? In other words, 0 is equal to 6, or let's just simplify it directly. 6C2 is equal to 2 times 3 is 6, so it's plus 0.6. معناته C2 is equal to 0.6 over 6, which is also equal to 0.1. I know you guys usually use A and B. If you want to use A and B, it's fine. Instead of C1 and C2, it's fine. It's just I'm used to writing it this way. And now we have found our second C2 value, which is our second constant value, which is C2. All right? Now we go all the way back to our general equation and we substitute for our C values. So we bring back this general equation and then هني 1 second. Okay. So عندنا هني C1, which is 0.3. So we remove this. We put 0.3, which is our C1 value. And our C2 value is 0.1. This is known as our particular solution. All right? Is this clear? Is this clear? شفتوا قلت لكم سهل. هو ما في شيء صعب فيه. هو just following steps. It is so easy. ترى والله, if you understand this, you're going to understand the higher order differential equation. There's just a few extra steps in it. بس if you know what you are doing here, you're going to know what to do there as well. Just a little bit more steps. All right? Ask your questions now. And then, for people who feel this is good and they understand and all of that, take a break. Yani we're taking a break until break till 11:20. All right. Whoever has questions, feel free to ask. Everyone else, you can take a break. I'm not going to start again until 11:20 at least. All right. 10-minute break. You guys want a 10-minute break or a 5-minute break? So vote in chat quick. 10-minute or 5-minute break. بسرعة بسرعة. 10 or 5. I see 2 10s. 20 انت روح دور ربعك. 5 10 5 10 10 5 5 10 10 10. Okay, 10-minute break. خلاص, we'll do it. Come back at 25. إنزين. خلني, let me look at, you guys can take a break if you understand the concepts. Everyone else, if you have any questions, I am gonna look at them now. نشوف C1 E1 cosine sin 1 why C2 is 0. علي, فهمت ليش C2 is 0? Again, C2 هني كان 0 لأن sin of 0 to C2 0. I'll die. Okay, from where? 0.6. 0.6 هذا is 0.3 times minus 2. All right, this thing I took it to the other side and it became positive 0.6. This is where the 0.6 came from. It's always product rule if it's the same. Yes, it's always product rule if it's the same general solution. Yes, مو شرط ترى. لا, it's always, yeah, for this general solution, yes, it's always going to be product rule. يعني for complex. Yes, will these type of difficulty come on the exam? This is not difficult. This is very easy. If you find this difficult, I'm sorry. يعني بصراحة, it will be very difficult for you to do higher order as well. لأن this is just following steps. And then you just have to follow steps. How to get B? يعني C2, you mean? For B? Noor, you were asking about how to get B. I will repeat the question. Don't worry. Don't worry. And then C2, how I got C2 is from this is the reason we did the differentiation in the beginning. So in a differentiation, then we have two boundary conditions and we have two unknowns. We have C1 and C2. فأول واحد حصلنا C1. ثاني واحد حصلنا C2. فأول واحد اللي هو theta, not theta prime, اللي هو theta, we plugged it in, اللي هو general solution مالنا, and we found our C1. Once we find our C1, now we can plug in our C1 back into this equation. Okay? And here we used our differentiation, اللي هو differential اللي سوينا product rule هني, to find the differential equation of this, or the differentiation of this. Then we plugged in our boundary conditions, اللي هو 0, 0. Everything will cancel out each other. We will only be left with C2 and numbers, and then we solve the equation to find C2, which was 0.1. All right. Does swapping C1 and C2 change the answer? Yes, if you have already, يعني, okay. If from here, from here, if you put C1 and C2 here, or C2 and C1 here, it's fine, but you have to stick with it throughout the entire thing. إذا غيرت C1 or C2 somewhere in the middle, it's a different answer. That is incorrect. So it depends on how you start your equation. All right. And it depends on what, يعني in this case, we have complex, but in distinct roots, it depends on what root you are considering as your M1 and M2 as well. It doesn't matter as long as you are plugging it in from the beginning the same and being consistent من البداية حق C1 and C2. Why did we use product rule? لأن we are trying to find the differentiation of theta. How are we going to differentiate this? The only way you can do it is using product rule, because we have two functions, two different forms of differentiation. We have an exponential times a trigonometric function. So we have to use product rule. So U times V. All right. ممكن تشرح boundary conditions الفكرة على السريع. السؤال هني قاعد يقول لنا given that when t equals 0, as soon as they say when t equals 0 you have a value for theta and d theta and all of that, this basically means this is your boundary conditions. يعني they want you to find your particular solution. This is what is meant by it. When you're finding t's 0, or when they don't give you an initial condition, this is basically meant as boundary conditions. That's it. إن معناته معطينك a value for when t equals 0 or t equal 1 or t equal whatever number. Most of the time it's 0, and then they tell you that theta will be this value. That's all. That's the only point of boundary condition. When you have them, you have to find particular solution. When you don't have them, you can only find the general solution. That's the idea of boundary conditions. All right? بيكون واضح في السؤال. ليش خليت ثيتا برايم يساوي صفر؟ لأن هني في السؤال معطينا d theta by dt is equal to 0. When t equals 0, theta is equal to 0.3. But d theta by dt is equal to 0. فالثيتا برايم مالنا boundary condition here is given as 0. تمام؟ Let's see. Any more questions? Guys, it might look complicated if you're just looking at me solve. أكيد طبيعي. ترى أنا لين اليوم حتى لو أنا فاهم السبجكت، إذا أشوف أرقام وأنا ما قاعد أحل من نفسي والله أضيع. لازم تحلون. حتى أنا when I was preparing for this session today, I was solving the questions myself even though I know this by heart. But I was solving the questions by myself احتياط، لأن sometimes even if you're looking at videos or if you're watching someone else solve or whatever, if you're not writing it down تضيعون. لأن يوم تكتبون أنتوا تفهمون من وين هالرقم وين هالرقم راح، كل هالسوالف. تمام؟ نشوف. Can you do an example with boundary conditions but with case 2؟ إذا حصلت سؤال كذي why not؟ بس I want to actually start with higher order differential equation. Inshallah tomorrow, يعني I will do more questions tomorrow after our session. Tomorrow's math session is going to be from 7 to 9, I believe, and I'm going to be going over the mock test. After the mock test, I will be giving an extra hour to solve extra problems, whichever you guys want. For now, I want you guys to just understand the basic idea. لأن الحين تقدرون المفروض تحلون أي سؤال من ناحية second order at least. But I really need to start higher order as well. So each case uses a specific differentiation rule, or can one case use multiple rules? شوفوا بصراحة من ناحية هني the only time you're going to be using product rule is when you have complex roots. If you don't have complex roots, it's very easy to differentiate. Technically, actually, if you have one root as well, and if we look back here at our equations, when you have one root, technically you will have to do product rule here for x and ER2x. So here you will be doing product rule. Here you could just differentiate directly. But here for this part of the solution, you're going to have to use product rule. The very first one, the general case, you don't need to use any rule. You just do direct exponential differentiation. And for case 3, you're going to have to do product rule for everything. Okay? Yes, don't worry, I'm recording the session. X equal 0. What do you mean by x equals 0? Someone was saying, how can I get, oh God, how did I get C1? Again, how did I get C1? The question gave me boundary conditions, okay? The boundary conditions were when t is equal to 0, theta is equal to 0.3. This means that we are going to substitute for t 0 in our general solution, like I did here. We're going to substitute for our t 0 and for our theta 0.3. Once you solve for this, you're going to get an equation with C1 by itself in it, and then you will find the value for C1. So, first step of this equation is writing down the actual given that you have. All right, so they gave you values for I, K, and F. Once you do that, you're going to do it into your characteristic equation or your auxiliary equation, اللي هو an m squared plus m plus 0.2 whatever. Then you're going to do your quadratic equation to solve. Once you're done with solving your quadratic equation, whether by calculator or by hand, you're going to get a solution. All right, here you're only doing algebra. You're going to get a solution. For this solution, for the roots, I should say, the roots, the way you will plug them in is you're going to have, in the case of a complex, you're going to have this general form. The alpha is going to be your real part, which is going to go over here. And your beta is going to be your complex part, which is going to be going inside the sine and the cosine, as you can see in this. This is also known as our general solution. Tamam? Once you find your general solution, you are done unless the question gives you boundary conditions or initial values. In this case, which is t equals 0, theta, when t is equal to 0, theta is equal to 0.3, and theta prime is equal to 0. This is considered a boundary condition or an initial value. So when we have these initial values, معناته now we have to solve for the particular solution. The way we solve for our particular solution is we need to solve for C1 and C2. And let me write that down. Solve for C1 and C2. How do you solve for C1 and C2? You're going to have two equations. You have two unknowns, right? You have C1 and C2. So you need to develop two equations to solve. This is why they gave you two initial conditions for theta and theta prime. Okay? So for theta, it's very straightforward. It's your general solution. You are going to be plugging in your value for time in your t, and you're going to be plugging in the value for theta in theta. Once you do that, you're going to be able to solve in such way. You're going to be canceling out whatever is there and here. The only thing that will be left is C1, and then you will get the value for it. Once you do that, then your second equation, you have to do the differentiation of theta, which is your general solution. To do the differentiation of theta in this specific case, you need to do product rule, which is u times v. All right. Product rule you determine your u, you determine your v, you do u v prime plus v u prime, you find your u prime, your v prime, and then you just add them up to find your theta prime equation over here. Once you find your theta prime equation, you're going to substitute the initial conditions that we had for theta prime and for the time into that equation. Once you substitute there, remember that we have already found our first constant, which is C1. We can plug this also into our equation here, which became 0.3, and then we can solve for C2. Doing algebra, you solve for C2, you get the value. Once you find your values for C1 and C2, you are going to find your particular solution, which is basically the general solution, but with the values of C1 and C2 plugged into them. Okay? Wow, 10-minute break وانا بعد ما لحقت اشرب ماي. زين. Let me take a break. I feel like I've been talking too much. Another extra 5 minutes. زين. And don't worry, I will stay in the session until we are done until we're done with up higher order differential equations. I'll be back in 4 minutes. I'm just gonna go catch my breath and drink some water إن شاء الله وبرجع لكم. تمام؟ أعرف إن الوقت قاعد يتأخر. I know some of you need to wake up early for whatever reason. If you cannot stay, I'm not saying يعني هيطردة, but if you cannot stay for whatever personal reason, do not worry. This session is being recorded and will be uploaded tonight as soon as I'm done with the session. I know you guys want to stay up. If you do, يعطيكم العافية. If you cannot, for whatever reason, it is fine. You can go get your rest. هذا this is my fault because I had to postpone it due to personal reasons. But inshallah, tomorrow we'll be starting on time for the mock test. And after that, I'll have some extra time to answer questions. All right. So again, the session will be recorded. I'll be back in a few minutes. Okay. Let us start with the higher order differential equation. Okay, what is meant by a higher order? Higher order معناتها second order. If you remember, second order we just did. Second order means we have y double prime plus يعني a y double prime plus b y prime plus c y equal 0. All right, for a homogeneous equation. This was our second order. A higher order will have more than just double prime. So you're going to have something like a y triple prime plus b y double prime plus c y prime plus d y equal to 0. All right. In this case, you're going to have the exact same cases as we had earlier, but they're going to be combined together. معناته. If you remember, here are the cases that we did. If I go back to them very quickly, the cases that we did, we had this general solution for two real distinct roots. We had this general solution for when we had one root or a repeated root, in other words, يعني the same number for both roots. And then we had case 3, which is complex roots. All right. It is the same cases as well for the higher order. ولكن شو اللي يفرق في الهاير order? We're going to have one additional case, which I'll go over in a bit. But first, let's look at the first three cases again in higher order. So when you have, for example, let's say y triple prime, and then your solution is going to have, for case 1, right? If I'm going to keep the same color code, I believe I used blue for case 1. Case 1 means you have real repeated or real distinct roots. شو معناته real distinct roots؟ معناته all the values are different. You're going to have y is equal to c1 e to the power of lambda 1x. Okay, because usually you guys use lambda for the solution here. You can use r, m, whatever, but we'll keep it lambda. c2 is equal to e lambda 2x plus c3 plus c4 plus up to cn, depending on how many real roots you're going to have. Maybe you have 2 real roots and then a complex root. Maybe you have all of them as real roots. Maybe you have one of them as a real root and then the rest as a repeated root. So it's all your real distinct roots up to cn lambda n x, meaning n is the number of roots. Okay, how many distinct roots you have. All right, I should actually say where you have n real distinct roots. This is for case 1. For case 2, it is when you have repeated roots. So يعني you have n repeated roots. Repeated roots, repeated real roots, I should say, right? So n repeated real roots, meaning your solution is going to be similar to last time. It was c1 e to the power of lambda x. Remember here, lambda is the same for all of them, plus c2 x lambda x plus c3 x squared. Sorry, this isn't lambda x, this is e power lambda x. All right, plus c3x squared e lambda x plus c4 c4x cubed e to the power of lambda x, and it will keep on going forever and ever and ever and ever for how many distinct real roots you have, but you're never going to get more than this many. So this is what it basically means. All right, I believe the equation given to you guys is a bit more different than this. I don't know what it is, the one that they gave you in class. Let me just see what it is. It looks very complicated. You have k and all of that, and do not confuse yourselves with the k and everything. This is basically what it means. معناته you're going to be multiplying by x. If you have 2 distinct real roots, you're going to, or 2 repeated real roots, this is going to be your part for it. And then if you have 3, it's going to be the first 3. And if all 4 of them are repeated, you're going to be having all these 4 as your solution. All right, this is what is meant by repeated real roots. Case 4 or case 3 was when you had n complex distinct roots. Distinct. What do you mean by n complex distinct roots? The highest possibility you're going to ever see is you're going to have lambda 1, 2 is equal to alpha plus minus I or beta times I, and lambda 3, 4 is going to be equal to, let's say this is alpha 1 and beta 1. This is going to be alpha 2 plus or minus beta 2i. I believe in this in the notes it says gamma and delta, but I like to keep it as 1 and 2 so we know what we are doing. All right. So you're going to have your first real and complex part, and then you're going to have your second real and complex part. And the way this will look in solving is y of x, your solution, all right, or just simply y, is equal to e to the power of alpha x, the same exact thing as we did last time, c1 cosine alpha or cosine beta x plus c2 sine beta x. All right. Let me make some space here. So you're going to have the exact same thing that we have already done. But this is going to be alpha 1 and beta 1 for the first one. And for the second one, it is going to be the exact same thing, but instead of 1, it will be 2. Okay? So this is going to be, instead of alpha 1x and C1, C2, here will become C3 and C4. So this will become alpha 2, beta 2, beta 2, and this will become C3 and C4. معناته you're going to have two complex solutions, and then two different complex solutions, and they're not the same, they're not equal. So two complex distinct roots. All right. You're just going to be doing this, and it will go on technically forever for a higher order, but you will never have more than this many in this case. And then we're going to have case 5, or sorry, case 4, which is the new case that we didn't see before. So case 4 is when you have n distinct or complex, repeated roots. معناته, what does this mean? This means that lambda 1, 2, 3, and 4 is all going to be equal to lambda 1, 2, 3, and 4 are all equal to alpha plus or minus beta I. All right. معناته you have these complex roots, all of them are repeated, all of them are the same. You will have the exact same equation as we had here earlier, with one minor difference being that now they're all alpha and beta. All right, we don't have any alpha 1s or beta 1s. Let me change the color so that there's no confusion. Okay, so we're going to have them all as alpha, beta. Just 1 second, just 1 second. All right, sorry about that. So again, e to the power of alpha x, all of it is going to be alpha, all of it here is going to be alpha and beta, all of it is going to be the same alpha and beta. The only difference is, just like we did in the case of n repeated real roots, we had to add an x. The same thing is going to happen here. We're going to add x to the e to the next one. That's the only difference. All right. Again, all of these equations might be given. I'm not sure if they will be given or not, but they're the exact same Exact same thing that we did for second order. Exact same concept. The only difference is here, you're going to have a combination of cases. You're not going to have a specific case by itself anymore. Okay? And we're going to look at an example of that right now. Let me look for a simple. Let's start with this one. So we have, the question says we have y triple prime plus 2y double prime minus y prime minus 2y is equal to 0. All right. So this is one example over here. The way you will solve this is, the first step you do is you're going to transform this into your auxiliary form or your general or your characteristic form, which is you guys are going to use lambda now. So lambda power 3 plus 2 lambda power 2 minus lambda minus 2 equal 0. All right, the same thing exactly we did a second order equation, but now for a higher order, we have it all the way up to lambda 3. Now, in second order, it was very easy because it's very easy to solve a quadratic equation. For solving any third or fourth order equation, the trick is to look at your last value over here, which is your minus 2 in this case. Okay? You're going to be looking at this value. This value, you're going to be factorizing it and testing. Basically, you're going to be doing trial and error. Yani, you're going to be looking at the factors of 2. You have 1 and minus 1, and then you have 2 and minus 2. And these are all the factors of 2. All right? So we are going to put the number and test out for 2. Yani, what do I mean by that? We are going to take one of these numbers, we're going to plug them into the solution and see if it is going to be equal to 0 or not. So we're going to say, now this is trial and error. Trial and error. Let's say, for example, I want minus 1. All right, let's say for lambda equal minus 1. We want to know, the idea now is we want to know if lambda equal minus 1 is a root of this formula or not. So what do we do here? We are going to plug it into the equation. So it's going to be minus 1 cubed plus 2 into minus 1 squared minus 1 minus 2. And we will check if it's equal to 0. So I go get my calculator. I just do minus 1 cubed plus 2 into minus 1 squared minus 1 minus 2. The solution I get is minus 2, which is not equal to 0. That means that this is not a root. All right, let's try. So we tried for minus 1. Now we can try for 1. Right? And this is how it works. Trial and error. You're going to have to try for each number until one of them sticks. So let's try for 1. So actually, let's make this a different color. Let's try for 1. So for 1, now lambda is equal to 1. Therefore, we're going to substitute it back into the same equation. 1 cubed plus 2 into 1 squared minus 1 minus 2 equal 0. I think I made a mistake here. 1 second. This is supposed to be minus 1. Maybe it was a root. Wait 1 minute. Let me double check. Minus 1 cubed plus 2 into minus 1 squared minus 1 minus 2. What do you know? It actually is a root. So here, I made a mistake. So we don't even need to try for this. I plugged in the wrong number. I plugged in 1 instead of minus 1. When you put these numbers, you're actually going to get 0 is equal to 0. So that is correct. So it is a root. All right? على حظي. So this is a root, meaning that we have lambda plus 1 is one of our roots, the opposite sign, because this is the root. In other words, yani when we plug in minus 1 into this, we are going to get 0. So this means that lambda plus 1 is one of our roots, all right, by doing trial and error. So we didn't even need to go for 1. So what is the next step going on from here? And then, what, for example, the last number was -4. Yeah, exactly, Khalid, the exact same way. So lambda plus 1 is one of our roots. What do we do here? There is this technique, I forgot what it's called. I think it's called simulation technique or something. بس بما معناه, we are going to look at our root. All right, so this basically means lambda plus 1 is one of our roots. And we are going to look at this equation one time. So let me bring this all the way down here. All right, try to focus here so you don't get confused on what I'm doing. So we know that -1 is one of our roots. So what am I going to do? I am actually going to make a table of some sort. And I will put the coefficients of what is above here. We don't care about the equal 0. We're just looking at this part of the equation. بنحط 1, 2, -1, -2. The coefficients of each one. And then I'm going to write them down here. The first value is 1. All right, this one. This one, we are going to take it all the way down to the beginning. And then we are going to be multiplying -1 with 1. So we are going to be doing a multiplication here. Times 1, -1 times 1 is going to be what? It's going to be equal to, let me color code these so you guys know what I'm doing. Let's start with red. So this, I am going to be multiplying here. So -1 times 1 is going to be -1. And we're going to put the answer that we get over here. All right, so this went over here. And then we are going to add this with the number above it. So this is going to be added together. Let me actually do a highlight so it's a bit more clear. So this value is going to be added with this value. All right. So it's going to be 2 plus -1. In other words, it's 2 minus 1, which is equal to 1. So now we got 1. Again, we are going to be applying the same exact thing. We're going to be doing this multiplication. We are multiplying -1 with 1. بيطلع لنا -1. Again, we are going to be adding this value over here. Okay? So we're going to be adding the values together. In other words, it is -1 plus -1. So -1 and -1 will become, يعني -1 minus 1 is -2. All right? Then, again, we are going to be doing the same exact thing. This value over here is going to be multiplied like this. All right? So again, this 1, we took it up here once we did the multiplication. Okay? Okay, so -1 times -2, -1 times -2, there's going to be multiplication again, gives us +2. So this will give us +2. All right, and then we're going to add again the value up and the value down. And here for the last one, you have to get 0. So you're going to add this with this number, and you're going to have -2 plus 2, you're going to get 0. All right. If you're not getting 0, that means you did a mistake in your original solving. You made a mistake in finding out this is not actually a root, because this 0 basically means it is the remainder. If you have a remainder, معناته this is not a root of your equation. تمام? This is one technique to do it quickly. Obviously, it took time with me because I'm explaining the concept, but if you understand how to do this, you can do it very quickly in the exam. If this technique is too complicated for you guys, what you can do is you can take your equation, which is this equation over here, and just do polynomial long division. So you're going to divide this with lambda plus 1. All right? And you're going to get the exact same answer that you would get if we did either or. All right? So this is it. This is just an alternative method, and I'm going to mention this here. This is just an alternative method. other method. All right? You're going to do the long division. So what does this mean? So we got our values 1, 1, minus 2, and 0. What does this mean? We got 1, 1, minus 2. All right? This basically means that we are going to have 1 lambda squared plus 1 lambda minus 2. This is going to be what is remaining of the factor once we take out lambda plus 1, which we have already identified as one of our roots. Okay, so the idea is you start with trial and error. Excuse me. You start with trial and error with the factors of 2, both positive and negative values. And then if you hit one of them, you always will, by the way, no matter what value here, you will, for third and fourth power, you always will hit at least one root by doing this method. Once you do the trial and error method, you're going to hit a factor. Once you get that factor, you can either do the table method or long division, whichever you prefer, to find out what is going to be the remaining part of your equation, because you are basically taking lambda plus 1 as a factor out of all of these values. So that is what you are doing. So we want to know what will be remaining if we took lambda plus 1 out as a factor. So once you do this method, you are going to get your coefficients here of what will be remaining. And we started with cubed, معناته هني this will be squared. يعني this is going to be squared. This is going to be lambda, and this is going to be no lambda at all. All right? This is how you can do it. All right? What is the point of doing all of this? So we know now that this equation is equal to 0. All right? This equation is equal to 0. So again, I'm just going to keep this up here so you guys know where you got these. Again, this 1 is here, this 1 is here, and this minus 2 is here. All right? We know that lambda plus 1 is equal to 0. So this is our first factor. What do we mean by factor, by the way? معناته إن this is equal to 0. This is what we mean. And now when this is going to be 0, it will be multiplied with anything else, and you will get your solution to be equal to 0. This is what is meant by factorizing and finding your roots. The whole idea of roots is finding what value will make the equation be equal to 0. This is the whole idea. So now we need to find what will make this be equal to 0, which is just a simple quadratic equation. You can remove the 1 here. It is a simple quadratic equation. You can either use the quadratic formula, or you can use mod 53 directly, or you can use factoring, whichever you want. In my case, I'm going to use the quadratic formula, which is minus b, which is minus 1, plus or minus the square root of b squared, which is 1, minus 4 times a, which is 1, times c, which is minus 2. Okay? Divided by 2 times a, which is 1. All right? So right now, this is just for the purple part. We are looking at the purple part. All right? Technically, we can call these lambda 2 and 3. Technically, because we have already found that our lambda over here, from the trial and error, our lambda 1 is equal to negative 1. We already know that this is our first root. Okay? So lambda 1 is equal to negative 1. So here now we are trying to find lambda 2 and 3 for this solution. Okay? Continuing, just doing the algebra, lambda 2, 3 is going to be, so minus 1 minus 4 times negative 2 is equal to 9. So minus 1 plus or minus the square root of 9, which is 3, over 2 times 1. If you notice, this was b squared minus 4ac. It was a positive number. So we're getting two distinct real roots. So in other words, we can say that b squared, we usually do it in blue. So b squared minus 4ac is greater than 0. So we are getting real distinct roots. Case 1. Okay? So Obviously, you can see that directly in your solution when you do it. So 2, 3 is going to be equal to, actually, let's separate them now. So lambda 2 is going to be minus 1 plus 3 over 2. And lambda 3 is equal to minus 1 minus 3 over 2. Lambda 2 is equal to 3 minus 1 is 2. 2 over 2 is 1. Lambda 3 is equal to minus 1 of minus 4 over 2, which is minus 2. Okay? So now we have broken down our entire, we have found basically all the possible roots. How do we know that we have found all the possible roots? So this was our last two roots, and lambda 1 from earlier, we have found it to be negative 1. So how did we find all of the roots? How do I know that I have found all of the roots? It depends on the order of the equation. So if we have a third order, we're going to have 3 roots, all right? If we have a second order, we're going to have 2 roots. If we have a fourth order, we're going to have 4 roots. So since we have third order, means we are going to have 3 roots. Doesn't matter what type of roots, whether they're distinct or not. In this case, we got them as distinct roots. But I will show you in another example how they will not be distinct. Okay? Once you solve all of this, now you are going to plug in back to our general equation. Since all 3 of these are distinct roots, so all of them are going to be applied for case 1, which is the simplest case, which is y is c1 e lambda 1x, c2 lambda 2x, blah, 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 as many roots as we have. All right? So it's going to be c1 e to the power of lambda 1, which is negative 1x, plus c2 e to the power of 1x, plus c3 e to the power of negative 2x. And this is your general solution. Since we don't have any values for input, this is going to be our general solution. Any questions? Is this clear? I will be solving one more that you have a mix of solutions, so you see how it will look like, and it's going to be fourth order as well, so you know what you have to do. طبعا there's a lot of different methods. Okay, there are times where you're going to have to do factorization, or you're going to have to take lambda as common, so you have to make sure you have techniques in finding out how you can factorize and simplify using different techniques. So I'm going to look over one of the techniques. Don't worry, I'm going to do trial and error again for another question, so you will see. I will be solving a hard one, but I need you guys to understand the concept of a simple one first. On what basis do we usually order lambda 1, 2, and 3? No basis. You could have called this your lambda 1 and 2, and you could have called this your lambda 3. It doesn't matter. Once you put them in the general solution, خلاص. التبتون هذا general solution as it is. It doesn't matter if this is your lambda 1 or this. يعني if you change them around here, it is fine. But it will matter once you go to particular. Just make sure you do not change after you find your final general solution. It doesn't matter the actual ordering of lambda 1, 2, and 3. All right? Let us look at a case. I'm not going to solve it fully, but I want you guys to look at, you know what? Let's solve it fully. And then, so, for example, I remember seeing this in one of the examples as well. Okay, let's do this example. So we have y, all right, so we're done with this. We have y to the power of, actually give me a second, let me see if this is similar to the other one I want to solve. Because I want to solve one with particular solution. Okay, no, it's not. Perfect. Okay, so we have y 5 prime plus 18 y triple prime plus 81 y prime is equal to 0. All right. Here, you might think this is a fifth order and it's complicated and all of that. It is actually a fifth order, but there is a trick to it and it is very straightforward. It's very simple. So how do you know? So first, let us find it in terms of lambda. So it's lambda to the power of 5 plus 18 lambda to the power of 3 plus 81 lambda is equal to 0. This is the first step, all right? Always your first step is making sure you know how to go into auxiliary form. Okay? Here, if you notice, we can take lambda common from the very beginning. All right? And most of the time, if you have a fifth order, this is the case. All right? So you're going to have lambda 4 plus 18 lambda 2 plus 81 is equal to 0. So here, right now, we can say our first root is lambda equal 0. This is our very first root. Lambda is equal to 0, or let's say lambda 1 is equal to 0. ليش؟ لأن إذا كان هني 0 lambda بنضربها whatever the value inside here is, we are going to get the solution as 0. This is what is meant by this is a root. All right, so we found our first root, which is lambda 1 is equal to 0. Now let us analyze the remaining, which is inside. This might look like complicated and it's a fourth order and all of that, but remember that this is also a form of a quadratic equation. How so? I am doing this just to simplify it so you guys see how to solve it, all right? Let u equal lambda squared, all right? Let's say u is equal to lambda squared, all right? For just the middle part. Now we're just analyzing the middle part. So we're going to get u squared plus 18 u plus 81 is equal to 0. صح ولا لا? Is this true or not? Did I say anything wrong? No. Well, I just said that I'm letting u to be equal to lambda squared, and then I will plug it in back into my equation. That's all I am doing. All right? Because if you notice here, now we have a quadratic equation. How did this happen? Look at this. Lambda squared, if we plug this back into u, okay? Lambda squared, if we plug it back into u, it is lambda squared squared. And then, and in other words, this is the same as lambda squared squared plus 18 lambda squared plus 81. That is the same exact case. Okay, I just wanted to clarify it for you guys so you guys can see it in a better and easier way. So you can say this instead. Now, just 1 second. All right. Now, we can solve this quadratic very easily. You can use either mod 5.3. You can use whatchamacallit. You can use quadratic equation. You can use mod 5.3. You can use factoring. You can use whatever. I'm gonna do for this case, for this one time, I will do mod 5.3. All right. So our u is 1, 18, and 81. All right. I get that u is equal to -9, and that's it. U is just equal to -9. So this is basically a distinct root. I mean a repeated root for this case. All right. This is a repeated root. Give me 1 second. This shouldn't be. هني عندنا 18, 1 plus 81. This should be negative. I don't know why this isn't coming out as negative. 1 second. Okay, yeah, I know why. And then, so this is, until now, we are just dealing with u. Okay, we're dealing with u. We know that u is equal to -9. And this is just one root. We only have one root for u here. Let us replace u by lambda squared. معناته بيكون عندنا الحين lambda squared is equal to -9. صح ولا لا? This is what we got now. We got that lambda squared is equal to -9, and we know that this is already a repeated root. All right? It's a repeated root for our second case. So here, when we do lambda squared is equal to -9, if we want to solve this, now we can directly solve this as the square root of -9, which is equal to minus 3, or I should say plus or minus 3 I. All right, this is equal to plus and minus 3 I. Why is it equal to plus and minus 3 I? The reason it is equal to plus and minus 3i is if you square plus or negative 3i, you're going to be getting this value as square root of negative 9. All right? Because remember, the square root of any number, the square root of 4, is equal to plus or minus 2. Realistically, we're talking about this. ليش؟ لأن if you do minus 2 times minus 2, which is minus 2 squared, you are going to get 4 because the minuses will cancel. And 2 times 2 is also 4. That is why the square root of a number is plus or minus the value. All right? So, in this case here, احنا عندنا plus or minus 3i. And this is it. This is the only root which is repeated for all of this. Okay? It is repeated for all of this. There is no other roots for lambda here. So in other words, you can say that this is lambda 1 and 2 are equal to plus 3i, for example, and lambda 2 and 3, or 3 and 4, is equal to the minus 3i. Remember that this is the same as saying 0 minus and 0 plus. So we have a real part, but it's equal to 0. Tamam? Before I move on, was this clear? If you do mod 5.3 and get only x1, it means that the answer is repeated. معناتها it is a repeated value. معناتها this is a repeated root, meaning u1 and u2 are equal to minus 9. This is what it means when you get only one value in your calculator. I'm going to repeat this entire part again because I need to make sure that you guys understand how to do it. لأن if you do it using this method, and then you're gonna have it as easy. Oh yeah, lambda 1 is 0. That will be lambda 2, 3, and 4, and 5. You're right. And then, so now we are looking at only this part. Hello? This, if we write it in a different form, if we want to forget about the u, you can say that this is the same as saying lambda squared to the power of 2 plus 18 lambda to the power of 2 plus 81. صح ولا لا? Equal to 0. This is what I basically said. But to make it easier to look at, عشان ما تخربطون ويا اللامدا ذهني, what I said is, let's say that u is going to be equal to lambda squared. This is all I said. عشان أقدر أكتبها as u squared plus 18 lambda squared اللي هو u اللي هو u plus 81 equal 0. This is what I meant by I let u be lambda squared. هذا بس أنا من نفسي سويته so I can simplify this. بعدين I will be plugging lambda back in. All right? So once you find the roots here, you're going to find that, let me do the full method. So u2, 3. The reason I said 2, 3 instead of 1, 2 is because we already have our lambda 1. So I don't want to use the number 1 again. So lambda, our u23 is minus 18 plus or minus, excuse me, plus or minus the square root of b squared, اللي هو 18 squared, which is 324, minus 4 times 1, which is our a, times 81, right? Divided by 2a, which is 2 times 1, يعني. All right? Meaning u23 is going to be equal to minus 18. If you do this calculation, you're going to get plus or minus square root of 0. Then, and divided by 2. What does this mean? Remember, this was b squared minus 4ac equals 0. معناته repeated roots. Right? Then, معناته repeated roots. Case 2, if you remember. All right, from previously. So this is repeated roots. So we know that we have U23 is going to be equal to minus 18 over 2, which is minus 9. معناته we have two values for U2 and U3. However, if we look at it from the case of lambda, if we substitute now lambda back in U, we are going to get lambda squared is equal to minus 9. All right? This is already a repeated root. فمعناته we can say that lambda 2 is equal to minus 9 and lambda 3 is also equal to minus 9. It is a repeated root squared, of course. زين لأن here we can say the exact same thing as well. This is as if we are saying u2 is equal to minus 9 and u3 is equal to minus 9. فالحين عندنا lambda 2 squared is equal to minus 9 and lambda 3 squared is equal to minus 9. But we still have this squared. For we have to take the square root again. All right. So it is going to be lambda squared. And I'm going to just name this instead of 3, 4, because you're going to see why in a bit. And then it doesn't matter again for the numbering. It's just so you guys can understand it in a bit when it's simplified. So if we take the square root of lambda, so lambda 2 is equal to the square root of minus 9, which is equal to I times the square root of 9 because we have a minus inside, which is equal to plus or minus 3 times I because we have the square root of 9. The square root of 9 is equal to plus or minus 3. تمام? So now if you notice, we have two answers. We have two technically solutions. We have lambda 2, 3 technically. صح ولا لا؟ لأن عندنا هني lambda 2 is plus 3i and lambda 3 is minus 3i. Or in other words, you can say lambda 2 is equal to 3i plus 3i and lambda 3 is equal to minus 3i. تمام? The same exact thing again will happen for lambda squared 4. هني the exact same method. We are going to get lambda 4 is equal to plus 3i and lambda 5 is equal to minus 3i. لأن it was already a repeated root and now it has become a complex repeated root. So now we have a complex repeated root. تمام? In other words, تقدرون تكتبونه as lambda 2, 3 is equal to 0 plus or minus 3i and lambda 4, 5 is equal to 0 plus or minus 3i. So what is this? This is a repeated complex root. اللي هو كان the last new case that we looked at. This one. We have the same exact values for alpha and beta for both, but they are repeated. So this is case 4. This is how you will find your case 4. This is the application of case 4. All right? Case 4. And remember, from early on, we have found out that lambda 1 equal 0. From the very beginning, at the very beginning, we found lambda 1 equals 0 that we took out as a common factor. Tamam? So now we need to build our calculation. Sorry, our solution, our y, which is equal to. Let's look at lambda 1 first. Lambda 1 is equal to 0. Which case was it? It was a distinct real root. So it's not repeated. It is not complex. It's a distinct real root. So we are going to put it as C1 e to the power of 0x, right? And then we're going to simplify. Plus, now we are going to look at lambda 2, 3, 4, and 5. These are case 4, which is complex repeated roots. And what was the rule for complex repeated roots? We are going to do the same thing as we do for real repeated roots. We're going to add an x, and then we're going to apply this equation over here, which is plus, let me make some space because I'm definitely going to need it. It is going to be e to the power of alpha, which is in this case, remember, this is our alpha, and this is our beta. All right. So e to the power of alpha, which is again 0x, times C2 cosine beta, which is 3x, plus C3 sine 3x, which is beta. This is the first part. Because it is repeated, we're going to have to do this again one more time. Make this a little bit just smaller on the side. So it's going to be plus e to the power, but now we have to add an x because it is repeated. E to the power of 0x, and then the exact same thing in the brackets, 0 being the real part, which is our alpha, C2 cosine 3x plus C3, it's not C2, now we have reached C4, C4 cosine 3x plus C5 sine of 3x as our solution. If we simplify this, e to the power of 0 is just 1, so it's going to be C1 plus, again, e to the power 0 is just 1, so we're going to just have C2 cosine 3x plus C3 sine 3x. Again, here we have e to the power 0, which is 1 times x, so it's going to be plus x. C4 cosine 3x plus C5 sine 3x. All right. You can take it an extra step, but you don't have to. You can group the cosines with each other and the sines with each other, and it will look something like this. You're going to get y is equal to C1 plus C2 plus C3x. And then, again, all I am doing is I'm taking the C2 here and the C4x. This isn't C3, this is C4, my bad. C4x. All right. I am taking these as a common. I'm taking cosine 3x as a common outside of these, plus C3, which is from the sine, plus C5 times x sine of 3x. Again, don't get confused. All I did was I took this with this times x. All right, as common. That's it. Again, you don't need to do all of this. As long as you may manage to go to this step, it is sufficient in my opinion. It shows that you're understanding and you know how to get it. I did want to solve more examples today, but it is really getting too late and I don't want this video to be too long. Inshallah, tomorrow after the session, I will be doing more higher order with different cases